Hey guys, I just want to record a quick video to go through an amendment to the cobalt chloride equations I spoke to you guys about during classes. So what I'm going to do is I'm going to share my screen. So in terms of the equations, the main one I wanted to go over was from the LCP prac because I want to go over a slightly different equation which actually provides more detail and allows us to explain the equation or what's happening a lot better. So I was going to go through both the reversibility prac and the LCP prac really quickly. So just to recap, in terms of reversibility prac, that's the one where we're heating it up, removing the water completely. Okay, and so we have cobalt chloride in two states. We have it in its hydrated and its dehydrated state. Now, in its hydrated state, what we know is that cobalt chloride is going to exist as CoCl2.6H2O. And we also know that CO, and this is going to be pink, right? We also know this is going to be pink. So let me change the color, style, it's going to be pink. Okay, so when it's hydrated, we get CoCl2.6H2O, which is pink. Then when it's dehydrated, it exists as just cobalt chloride, which we know is going to be blue. Okay, so for this prac, then we get the equation of CoCl2, which is solid, plus 6H2O, which is liquid, in equilibrium, with CoCl2 brackets H2O6. Something that I would point out alongside this though, is when we actually write this equation, we kind of oversimplify it because the cobalt chloride is actually going to separate out and it doesn't actually exist alongside its chloride ions. So what we would actually get is something a bit more like this if we were showing an ionic equation or my full ionic equation. Okay, so this would have a charge of 2 plus because the cobalt is 2 plus and the water is neutral. And then we have 2 chloride ions, which would also be floating around in solution. Now, this compound here, cobalt chloride hexahydrate, is actually known as a complex, which I mentioned during class. And I'll speak about what that actually means in a second. So in terms of the LCP prac, we're going to be focusing more on this part here, which is how cobalt chloride actually exists in solution. And like I said, it actually exists as what is known as a complex. Okay, so the next question is, what the heck is a complex? Now, a complex is a specific type of chemical compound, and what it is, has a central ion covalently bound to surrounding ligands. Okay, so ligands are just things which surround a central ion in a complex and they covalently bond. Okay, surrounding ligands. So let me give you a quick example, and the example I'm going to show you, because it is one we're going to use anyway, is the example of CoCl4, which has a charge of 2 minus. The reason it has a charge of 2 minus is cobalt is 2 plus and Cl4 is minus. Okay, so this is going to be 2 minus. So in this case here, what we would have is we would have cobalt in the middle. Okay, so cobalt would be my central metal ion, and it's going to have a charge of 2 plus. Okay, and it's going to be surrounded by my chloride ions, and each of my chloride ions covalently bond to my central cobalt. Okay, so it's going to end up looking something like this. And I just drew a Lewis dot diagram so we could very clearly see the fact that it was a covalent bond. Now, overall, we once again said the charge would be 2 minus, so I'd have my square brackets and 2 minus, okay? Don't stress too much about what a complex is for now, but just know that a complex is something, it forms a complex in solution, and that's why it has these unique colors. That's the main thing. Now, what I'm actually going to do is I'm going to change this color, because what color do we know cobalt chloride is in solution? Sorry, CoCl4 is in solution. It's actually going to be the blue part of my solution. Okay, So this forms a blue part of my solution. Let me just change that color to blue. I'm probably going to change the color of some wrong things as well, but that's fine. I missed one of my electrons. Okay, so cobalt chloride in solution is blue. Now the other thing, or the other way that it also exists in solution is as the other component, which is my cobalt hexahydrate. Okay, and cobalt hexahydrate is that pink part that we mentioned before. It's also known as a complex, okay? Or cobalt hexahydrate is also a complex, but it's pink. So the equation that we actually have for this, this equilibrium is cobalt chloride or cobalt tetrachloride, so 2 minus, reacting with 6 waters, which are liquid, to form 4 chloride ions plus cobalt hexahydrate. And this is the equation I want you to use whenever you're talking about this PRAC or the LCP PRAC for cobalt chloride hydrated, okay? Now what we have is just like we said, the cobalt chloride is blue and the cobalt hexahydrate is pink. And just like we spoke about in class, the formation of cobalt chloride hexahydrate is going to be exothermic, okay? So when we add heat, it's going to shift towards the left, which is actually the dehydration of cobalt chloride. Okay, if you guys have any questions, make sure you post them up in Slack and I'll get back to you guys with any questions that you have. Awesome. Have a good night, guys.